Today, we are going to talk about the fundamental theorem of algebra. What does fundamental mean? Basic? Important. Those are the two words that come to mind for me when I think of fundamental. I think that it's a basic idea and it's super important. So if we play basketball and we have a really bad game, the next day at practice, our coach might tell us we need to go back to fundamentals. What kind of things would the coach be talking about? Dribbling? Shooting, like simple shots, like layups, free throws, passing, defense, boxing out. These kind of things are really, really important in basketball. Like if you can't do these things, you're probably not going to win games, right? Dunking, awesome. It gets the fans going, but you can win a game without being able to dunk, right? So fundamentals, basic, super important, necessary. So our fundamental theorem of algebra is like the big idea of algebra. What the fundamental theorem of algebra says is if f of x is a polynomial, so polynomial means that we have powers of x, then when we set the equation of f of x equal to 0, it says it has at least one root in the set of complex numbers, or one solution. Another word for root is solution. So then we have at least one solution. So what this tells us is every polynomial equation is solvable. We can solve every polynomial equation. It says it has at least one solution in the set of complex numbers, which means the solution might be imaginary, but every equation is solvable. Okay? That's a really big idea. So that's our fundamental theorem of algebra. Basic and super important to the idea of algebra is that we can solve equations. So some things that follow from that, it says that including repeated zeros, and we'll talk about what those are in a moment, a polynomial has the same number of solutions as its degree. Degree means highest power. So if it's an x to the 5th equation, we should expect to have 5 solutions. If it's an x squared solution, we should expect to have 2 solutions. If it's an x to the 8th equation, we should have 8 solutions. Whatever that highest power is, that tells us how many answers we should have. The next bullet point says a function that bounces off the x-axis. So if it hits the x-axis and it turns right back around, it doesn't cross it, but it just hits it and turns around, that counts as like a bonus. It's a double solution. We get to count that answer twice. And then our last thing says that imaginary roots happen in pairs. You will never just have one imaginary answer. From what we've done with imaginaries already, why do you think that is?
Because you can either have a positive or a negative number of each.
Whenever we were solving, got imaginary answers, we always had that plus or minus 3i. So that gives us 2 solutions. That plus or minus will always make imaginary numbers come in pairs. So today we are going to work on finding all of the solutions to a particular equation. If you pay attention to the section numbers that we're doing a little bit of shuffling, but we're also doing some skipping. We're going to skip a couple of sections in this chapter that teach us how to do this first part by hand, because I don't really want to. So since we have technology, we should use technology to our advantage when we can. So we're going to begin by using our graphing calculator to graph the equation and see how many solutions we can find that way. So please take out your graphing calculators. So what we're looking for is solutions or x-intercepts, places the graph crosses the x-axis. I see a couple things. What do you see? See that it crosses at -2. So you should see it crossing at -2. Each of those little tick marks on your calculator counts as 1. So that crossing then is at -2. What else do you see?
Intersection at 1.
It intersects at 1, and it's a special intersection because it bounces. So a bouncing intersection gets to count as a double solution. So I see 3 solutions then. I see a solution at -2, and I see a solution at 1 that we get to count twice. So I see 3 answers to this question.
What is bouncing?
Bouncing means that instead of crossing through the x-axis, it just hit the x-axis and turned right back around.
Okay, and I have another, like, on our calculators, it's kind of like Isn't it like a straight line? So how can you tell exactly where it crosses? Like,
Can you like calculate?
On your homework, I'm going to just give you places where it's crossing nicely, so we can just kind of use those tick marks to help us out. I'm not going to give you ones where the solution is like 0.8743. So if it looks like it's crossing one tick mark over, we're going to say that's at 1. Okay, so I'm just going to give you ones that are nice solutions. All right, so we found 3 solutions on our graph. How many solutions should we have?
5.
Why should we have 5 solutions?
Because it is x to the 5th.
Because it was x to the 5th. So that means we are missing 2 solutions. What do you think about those solutions? They're imaginary. We cannot see imaginary things, right? So if we can't see them, they must be imaginary answers. So we have 3 real answers, and we're going to have 2 imaginary answers. Yes?
Is this just the x-axis?
Yes, just the x-axis is all we're concerned with.
Are those lines are the same lines, right? It just goes.
Yes, yeah, we can't see everything that's happening, so it is just one continuous equation. We just can't see the whole thing on our calculator. So step 2 of the process said that what we're going to do is use synthetic division with the solutions that we found to work our way down and be able to find the remaining solutions. So we learned synthetic division the other day. We learned that we start by writing out the highest power that's in the problem. So that'd be x to the 5th. And count our way down. Write out our coefficients. So our coefficients, I had 1x to the 5th, negative 2x to the 4th, 0x cubes, 8x squared, negative 13x's, and 6 was our constant.
What were the zeros again?
Yeah, the zeros that we found, the solutions that we know so far is we know we have solutions at negative 2 and then 1, which we counted double. So now what we're going to do is use those solutions to plug in with synthetic division. And it doesn't matter what one you do first, so I'm just going to start by plugging in negative 2. When we learned synthetic division the other day, we learned that we carry down the first thing, multiply, and add. Multiply. I feel like I did something wrong.
Yeah, negative 2.
Yes, it's negative 2. Thank you. So then I'm going to have negative 4. That's 8. 8. Negative 16. Negative 8. Positive 16. Positive 3. Negative 6. 0. You must end with a 0. If you do not, you've done something wrong, because what we're plugging in should be a solution, and solutions will always give us a remainder value of 0. What we are going to do now is plug in another solution to this answer. So not going back to the original, but from here, I'm now going to plug 1 in. Carry down the 1, multiply, add, multiply, add, multiply, add, multiply, add. From those numbers, continue on. So don't go back to the beginning. From where we are, plug in the next solution. The solution of 1 counted twice, so we're going to plug it in again. Carry down, multiply, add, multiply, add, multiply, add. And each time we're working our way down so that we'll have 1 fewer number to be working with. We should always get those zeros as the last thing. We learned when we learned synthetic division that if we start with an x to the 5th after doing one set of division, where are we? X to the 4th. So after our first division, we were at x to the 4th, and then we divided again, so that would bring us to x to the 3rd, and then we divided again, so now we're at x squared. So 1x squared minus 2x plus 3 is where we are now. That's a quadratic equation. We learned how to solve quadratic equations back in chapter 5. So our final step, step 3, is now solve this quadratic equation to find the imaginary solutions that we couldn't see in our picture. Correct. So, best way to do this is the quadratic formula. So we learned that quadratic formula a couple weeks ago, a week ago.
Wait.
Isn't it like negative?
So A is going to be 1, B is going to be -2, C is going to be 3, and we're going to plug it into the quadratic formula. So x equals -2 plus or minus the square root of -2 squared minus 4 times 1 times 3 all over 2 times 1. I'm going to address a couple of common mistakes that happened on your test. First thing, I think that several students probably plugged in what was underneath the square root into their calculator, but without using parentheses. And remember that a -2 squared in parentheses is different than just typing -2 squared. Okay, I think this happened a lot on the test, so be careful about that. I want to square a -2, that's really positive 4 then. So 4 minus 12 gives me -8 under there. Second super common mistake that happened on the test was that students divided at this point. We cannot divide things that are underneath a square root with things that are not underneath a square root. They're not alike. We can't combine those. So we cannot divide yet. We need to simplify that square root. Question?
-2 squared is 4.
Mm-hmm.
Why is it negative?
Minus 12. 4 minus 12 gives -8. So we need to simplify that square root. What do we break 8 down to be? 4 and 2. Take some square roots there. And I get x equals plus or minus 2 times the square root of 2i all over 2. Now we divide everything by 2 and get 1 plus and minus the square root of 2i. That's 2 solutions, because plus and minus, along with the 3 solutions that we found before, give us the 5 solutions to this equation. These problems are long. I know they are. So while you are busy kind of cursing me for how long these problems are, you can also be thankful that I did not make you find -2, 1, and 1 by hand. It could be worse, right? We used our calculator to start this problem. It could be worse. I could have made you find all of the solutions by hand. So our final answers are the 5 solutions, -2, 1, 1, and 1 plus or minus 2 root I, square root of 2i.
And you only give us 5 problems.
And I did not give you a lot of homework questions. That's true. So your homework is short. So let's go ahead and look at the next question. So the next question, problem number 2 in the notes, you're going to begin by plugging that into your calculator. So go into your y equals.